Today's job, I am processing source trees. So these are published trees. So I'm constantly compiling databasing source trees for synthesis process in insects, and here's a published tree which I will process today. These are the authors who have kindly made the file available. So in processing source trees, it depends very much on how the authors have presented their work. Some publications, they don't actually make a machine readable phylogeny available. So you can either request one from the author, or you can just manually write it out yourself, or there's software to automatically extract this, which may or may not work well. But in other cases, the authors do make the machine readable phylogeny available online, associated with a manuscript, and they have done so here. So I'd like to make a record of this process. So I'll probably make at least two videos. One will show the process of processing a source tree which has a machine readable phylogeny available, and the second video I'll do it on the manual of creating a NUIC string where the machine readable version is not made available. So today so you can see the phylogenetic results. This is a phylogeny of a Hemiptera superfamily, and it's an omics tree, so always high support. And they made their data available on Figshare. So I've downloaded that, and these are in here. So there's several trees available. I'll just take them one. I'll just process one at random. Now, in processing a tree, probably 95% of trees need some kind of adjustment if they are to be used in synthesis. Now, I don't know at this point what is required, and I've just effectively chosen one at random and go through the process of doing this. So first thing we need is, let's go to the folder of scripts for processing previous source trees, and we just modify one accordingly. So because each published source tree is slightly different, and it needs slightly different things doing to it, I've actually just got written one for each machine readable source tree. Just for reliability, if I ever come to replicate again, so I'll just choose one. Actually, first thing is just to look at the file itself. So we'll copy it into the working directory. Change the name to something a bit shorter. And take a look. So we just use look at the contents of the file. So just use cat. Let's see what we've got. So NUIC string, it's NUIC format. Not two main formats you'll encounter are NUIC and Nexus. Majority are NUIC, and this is NUIC. Nexus will have a bit more complicated. It will have some other details, but NUIC's usually just string is on a single line. Okay, so we have, and these are terminal labels, anything between a comma and a bracket is a terminal label except for the node labels. So here's a terminal label. We have a presumed species name underscore, so genus name underscore species name, and we have something else. So we have some, so they've put some codes on here. So these codes, these are specific for the study. I have no idea what these are, probably corresponding to some specimen data or some sequencing run or something. So it's quite common for people to add certain append information to the taxonomic names. So we can see some. So these, we will remove these. There's about one job. Just need the Linnaean information. Second thing, we notice some non-standard. So we don't have a simple. I don't even know if this is a taxonomic standard to have this. It's not a regular species name. So I need to decide what to do about this. The codes all seem to be the characters CMF underscore then a number from a quick look, but we'll check that later. We have, okay, so we have after each close bracket we have a number, colon, then floating point number. So before the colon, that is a usually node support. After the colon, that is branch support, branch length. Okay, so we have. Okay, so I can see. Yeah, so this is so because this is 0.95 and this one is 1, and these are always, omics data is always high support, so that means this support is between 0 and 1, which is one format. An alternative you'll see sometimes is between 0 and 100. Percentage, in other words, but here we have a proportion, and then okay, so we know what we. I'll just notice another. So we have here SP. That means undetermined species. So this is ambiguous. Second thing, another thing I'll point out. We have here we have a given genus. Melancanthus, and we have one terminal which has a fully identified species, and sister to that we have a species ambiguous congener. Now this is something that takes some thought. During processing I have decided to remove these. If there's a named congener, then I opt to remove the unnamed one. Now this does reduce some of the information content because these are informative on, it gives you evidence of monophyly, is this genus monophyletic. However, because the application of this process data is synthesis phylogenetic, these are quite problematic to integrate with other source trees if you have named. So for that reason, I opt to remove these. Again, we have another species ambiguous terminal, and we have okay. So we have some inconsistent labeling. So notice this one has SP, then a 3-letter code, then the CMF code, and then this one does not have this 3-letter code. It goes straight to the CMF. So we have some that will need accounting for when we parse this. Okay, so now we've had a preliminary assessment of what we'd need to do. So here's one script we may base this on. So we'll just copy. Here's an old script for processing a previous source tree. We'll just copy this and start a new one specific for this one. Quick look over this, what we've got already. The first $argv, these are this reads into a variable what is placed into the script. Any strings placed into the script at the command line upon running the script. So that means you can put these file names here. Open the file, scan through each line and look for a tree, put it into a variable, just report on the tree length, and these will all need rewriting here. Remove branch lengths, print the tree, and write to an output file. A few things we don't need. Okay, let's just run this. So let's just read the tree in first and then print it. So we've removed branch lengths. We don't need, for our purpose, we'll just simplify it. We don't need branch length and don't need support. So node support is given after a split, and splits are the end of a split information is denoted by the closed bracket. So when we have this and its floating point, so we'll need any character 0 to 9 or a period, and then multiple. Okay, so remove node support. Okay, so these, as I allude, these are not this is information for the authors who did this study. Otherwise, it cannot be used more widely. The only information we can use is the Linnaean taxonomic information. So we just need to, next job is to remove these extra codes. So copy these, put it into a regular expression, use the while loop, I think. So we've got, okay, I've just noticed another variant which we'll need to address later. So we start a terminal label with, so we'll get the preceding character will either be a comma or a open bracket. So we'll get it precise as possible. Open bracket or comma. And then we have an uppercase character, multiple lowercase characters, underscore, multiple lowercase characters, underscore, the string uppercase CMF, and then 4 digits. And then either a close bracket or a comma. And we're deleting this string, and so we'll be remaining the taxonomic information and the preceding and the string, the character before and after. So we'll put a parentheses around these just to capture the things we are keeping, and then we'll be deleting this and keeping this. So then we have item 1, 2, 3. So $1. So most of these have now been changed already, so we'll figure out a few which haven't, why they haven't, and we can see this one has not 4 but 5 characters, so we'll change this from 4 to 5. This one has 2 sets of numbers on it. So we duplicate the expression for the 4 numbers. Here has some location information. So as you can see at this point, every tree, despite it's been made available, every nuke tree is slightly different in some way, and everyone needs some specific processing, custom processing. So it's the only location I noticed after, based on a quick scan, but we'll just insert before the insert here. Uppercase word. Okay, that's got it. So we have some, I don't know what this means. I don't know if it's the more common taxonomic abbreviations I'm familiar with, like NR, AF, SP. Now V, I don't remember encountering this one before. It could be a standard abbreviation which refers to something, or I'm not sure. So I don't really know what this means. I think I'm just going to change this to SP, which is undetermined species. So we have uppercase, lowercase, underscore v underscore a word, lowercase word underscore CMF and back digits. Replace this with item 1, 2, 3. So we just add the SP to denote it's undetermined. Okay, that should work. Okay, I've just noticed another NR that needs dealing with. So where were we? There's this V. Here we could notice. Okay, so we just change that to SP. Now we have NR means this is a standard taxonomy term. It means it's probably this species. So this one I usually keep because this is what is widely used. So we'll just capture the whole of this, i.e. the whole of this. Okay, looks fine. So we're looking for this. Okay, yep, we've trimmed off the. Okay, I see another one here. Yeah. So NR, this looks like a genus name, then a code. So I interpret that as meaning this terminal is probably this genus, species totally unknown. So good question what to do with this. This is not particular, you don't see this very often. What I think I'll do for the time being is I'll just keep it with this genus name. We'll assume it's that genus. So we're capturing the character preceding the string, ignoring this, and just getting the genus name and underscore SP, ignoring this component, and then the character after it. So that's 1, 2, 3. Okay, should work. Where is this? Yeah. Okay, so we've replaced it with this. Looking for any more terminals that need processing, and I don't see any now. Maybe we've finished. Okay, so we'll now and then pin that to output file, which we have called this. And so the Perl script check terminals. Let's just take a look at this. Always a good idea to, if a script you use multiple times, just write some notes about what it does. And here I have written, after a bunch of different scripts, each processing a specific published new. This checks the result of a process and checks the terminals conform to various specifications. So reading the tree and okay, doing a bunch of things. Let's just run this. And here's the output of this. So you can see what it's doing here. It's checking whether the terminal appears like a standard binomial. So ideally all the terminals have a genus name and species name, but this is not always feasible. Some things are difficult to identify, some insects are difficult to identify, sometimes not the expertise to do it, or sometimes it's too much material to identify everything, and so on. So these have been identified to genus level, but not species, which is very common in insect studies. And now we have this script is also checking for repeat terminals, which you cannot have in a phylogenet. You can't have two terminals with the same name. This will break a whole lot of downstream analysis. So it's found this after the various processing we've done. So we need to. This would be informative, as I mentioned earlier, for certain applications like checking monophyly, but for synthesis, this is it's going to cause us various problems. So I opt to remove these species ambiguous congeners. So a few duplicate terminals need trimming, and here it's assessing whether they have. So if you have a terminal which is ambiguous at the species level, named at the genus level, and there's no other representatives of that genus, then that's informative in our current instance. So this script is testing this. But maybe that's enough for today. I wanted to make a note of simply the processing a source tree, and just to state that some of these will be a few of these terminals now will be pruned, but summary for today, we've processed a machine readable phylogenet which has been kindly made publicly available by the authors of alongside their publication. Now these always need some minor processing. As you can see today, there's various strings, often informational strings, which are attached to the terminal labels. Now these, at least the good thing about, in this case, these were standard. You had the taxonomic name, and then the information string was put afterwards, so this is correctly fielded. Sometimes you'll notice it can be in different orientations, but this was relatively easy to process, and it's left with a Nuix string with just taxonomic labels. So this is more integratable to other source trees. Okay, so job done. Till next time.